Today's video is going to be on single replacement net ionic equations. Okay, so single replacements. Get this moved around a little bit. This is in your packet of notes here, just single replacement section. These are redox. Okay, single replacements are redox reactions, just so you know. Turn there. So remember, it's always an element, single element compound. This is in solution. This is a solid. So solid in solution right there. It'll always produce something in solution plus another solid. So if you think about it, these reactions, this element by itself here has to be more reactive than the element it's trying to replace. So remember, metals replace metals. So lithium has to be more reactive than calcium in order to replace it, and lithium is more reactive than calcium. If we think about this as it goes, lithium is a solid right here. It will be aqueous over here. So it's dissolving. So it's going from 0 charge to a positive 1 charge over here. Calcium is dissolved. It's part of this compound that is aqueous. It's dissolved, has a +2 charge, so you can't see it initially. Going to a 0 charge would be solid over there. You'll be able to see solid calcium at the end. Okay, so it is redox. So there will always be a spectator ion, one spectator ion in single replacement reactions. Always be one spectator ion. So if we wrote this out, you have lithium plus, this will split apart into ions. So you'd have calcium ions plus chlorine ions. Now there'd be 2 chlorine ions, but we won't have to worry about that quite yet. Forms, this would be split. Lithium chloride is soluble, so plus lithium plus chloride ions plus some solid calcium. Spectator ions in this case would be chloride, so get rid of chlorides. Make sure our atoms are equal. 1 lithium, 1 lithium, 1 calcium, 1 calcium. Make sure our charge is equal. Well, it's a +2 and a +1, so that charge is not equal. So we need a 2 in front of there, 2 in front of there. It is redox. Lithium is going from a 0 up to a +1, so that is being oxidized. It's losing electrons. Calcium ions are being reduced from +2 to solid calcium with a 0 charge. So electrons are being transferred from there to there, 2 electrons total. 1 per lithium, there's 2 lithiums doing that, and 2 electrons per calcium ion. Let's do another one that's not on this page. So let's say we have some fluorine, which is a gas. It is diatomic, reacting with some, let's say potassium bromide. So fluorine's a halogen. Halogens replace halogens. So fluorine's going to go over here and replace it. Fluorine has to be more reactive than bromine, and it is, in order for that to happen. Sure, that was just hitting save. So fluorine replaces that. We end up with potassium fluoride. Bromine is kicked out, plus bromine. And bromine is diatomic. Bromine is diatomic. This would be aqueous, and this would be aqueous. So those should be split apart into ions. Okay, they should be split apart into ions. So if I write those as ions, we'd have K plus ions, Br negative ions. K plus ions, F negative ions. Well, our spectators there would be our potassium ions. So we can get rid of potassium. Again, there's always going to be one spectator ion in a single replacement. Make sure our elements are equal. 2 fluorines, 2 bromines, 2 bromines. Again, single replacements are always redox. Singles are always redox. So fluorine's going from a 0 charge to a -1 charge. It's going down, so it's being reduced. Bromine's going from -1 up to 0. It's being oxidized. Again, fluorine is not aqueous here. It's solid, actually. There it's aqueous. Bromine is aqueous, and there it is out of solution. It's actually a liquid. Transfer of electrons. Fluorine is being reduced, reduction is gaining, electrons are going from there to there, it's 2 electrons total, 1 for each atom. One thing that's important here. Metals from family 1 and calcium, strontium, barium will replace hydrogen when placed in water. So potassium, put in water, those things have the ability to replace a hydrogen. They have the ability to replace hydrogen. So you end up with KOH plus H2. They make the strong bases. That's how strong bases are made. So remember, calcium, hydroxide, strontium, hydroxide, barium, hydroxide are considered strong bases around the family 1 with hydroxide. So if I put any other element, like zinc in water, magnesium in water, those elements will not replace the hydrogen in water. These will. So if we write this now, this will split apart into ions because it's a strong base. So this should be written as K plus OH negative. Make sure it is balanced. So I think we need a 2 in front of this. That gives us 4 hydrogens, and a 2 in front of that. Maybe we did not need that. If we look now at our overall reaction, remember it's only family 1s that do that. Okay, only family 1s that will do that, just so you know. So again, family 1 and family 2 elements will do that. If we are balancing this, we do need a 2 in front of that because our charges have to be equal and a 2 in front of that potassium as we're balancing there. If you're doing calcium with water, the calcium can replace the hydrogen, so you end up with calcium hydroxide plus H2. Always makes a strong base. Okay, the only elements that will do this will make a strong base, so that should be split apart into ions. So you'd have calcium ions plus hydroxide ions. Your calcium is a solid over here, is being dissolved. So we're going to calcium plus 2 moles of hydroxide ions. We need a 2 in front of there. If we think about what's oxidized and what is reduced, calcium is going from a 0 to a plus 2. It's going up in charge. Calcium is going up in charge, so it is being oxidized. Hydrogen right here is going from a positive 1 to a 0 charge. Not every hydrogen is being reduced, but 2 hydrogens are being reduced. Some hydrogens are staying as a positive 1 charge. All right, that's all I got.